Hi, your nines, it's Mr. McNaughton. You probably recognise my cheery, inspirational voice. I'm going to go through the first of the fact sections in the fact book, the first 4 facts for your first lesson, just now using this PowerPoint. Now, obviously, there are some things on the PowerPoint slide you can see just now that aren't mentioned in the fact books. We won't necessarily cover all of those. We may touch on a couple of them because they link quite nicely to the facts in the fact book, but just make sure you are learning those facts as they are listed for each lesson, and you'll be up to speed with where we want you to be. Now, it is revision, so hopefully it will ring a bell as we go through it, but obviously it's been a little bit of time since we covered it, and obviously there have been unprecedented events in that time that understandably have possibly put things like schoolwork and science and things like that possibly not to the forefront of your mind. So this is what will hopefully help jog your memories and revise some of these key points moving forwards. So we're going to look at what atoms are made up from. We're going to look at what we call subatomic particles. Those are the particles found within an atom. And we're going to look at some of the key properties. We're also going to look at some of the information we can derive from or about, excuse my dogs if they go mad, they're a little bit twitchy today, some of the key information we can derive about an atom using what we know about these subatomic particles. So first of all, if you want to pause the video just now, you don't have to, but if you want to pause it and have a go at drawing a labelled diagram of an atom, showing the nucleus and labelling what we call the protons, neutrons and electrons and shells, just to see how well you can remember it yourself, you can do that just now. Okay, so hopefully if you were going to do that, you've had a go at it, we can see how accurate you've been. Now, generic diagram of an atom would look a bit like that. Okay, you have a nucleus in the middle, containing 2 types of the subatomic particles, we'll come back to those in a minute, and you have shells around the outside containing the 3rd type. Now, if you're in my group or in certain other teachers' groups, you will have watched a little video on YouTube where a guy explains the structure of an atom to his friend whilst they are stuck in a cupboard for some reason. If you haven't seen the video, then it will seem like a slightly odd reference, but hopefully it will make sense. And he talks about the atom being a neighbourhood. He talks about 2 gangs hanging out in the middle of the neighbourhood, what the gangs he refers to as the pros and the new boys, and he talks about the other negative gang that circles the neighbourhood, and they are what he calls the elected ones. Okay, and that's how he gets his friend to remember the names, because the pros in the middle, they are the protons, the new boys in the middle, which are the neutrons, and then the elected ones round the outside, which are the electrons. Okay, so moving on from that to look at some of the key properties. The 2 main properties you need to be aware of are the mass of the each subatomic particle and the electrical charge. Protons are positive. Now you can remember that nice and easily. Protons begins with P, positive begins with P. They have a charge of +1. Okay, you can also remember it. Pro means in favour of something or being positive about something. So they are positive, they have a charge of +1. They have a relative mass of 1. There are no units for relative mass. The relative mass is just comparing the mass of one subatomic particle with the other subatomic particles. So it's the mass of that particle relative to the others. So protons have a relative mass of 1. Neutrons have no charge, or they are neutral. That's the way to remember that. Neutrons are neutral, they have no charge. All of those things begin with N. Neutrons, no charge, neutral. Easy to remember. They have a relative mass of 1 also, so the same mass as protons. Electrons are negative. They have a charge of -1. Each electron has a charge of -1. There's not really an amazingly easy way to remember that, but you will remember the first 2, and therefore electrons, it's quite easy to fill in the gap and say they are negative. Protons +1, neutrons 0, electrons -1. Now electrons have a very, very small mass. They have a relative mass of 1/2000. That means you would need 2,000 electrons to make up the mass of 1 neutron or 1 proton. So they are tiny. All 3 subatomic particles are very small, but electrons are the smallest by some distance. So when we talk about the mass of an atom, we usually talk about, we talk about it specifically in terms of the number of protons and neutrons in that atom. Now, in terms of where we find these, the protons and neutrons are found in the nucleus of the atom, in the centre. The electrons are found orbiting the nucleus in shells round the outside. So if we go back to our original diagram, you have the protons and neutrons in the middle, you have the electrons in the shells round the outside. Now, remembering what we've just said, protons have a charge of +1, neutrons have no charge, so the overall charge of the nucleus is positive. Electrons have a charge of -1, they are negative. That's why they orbit the nucleus. They are held in that orbit by the attraction between their negative charge and the positive charge of the protons in the nucleus. Okay? And positive and negative attract, that's why the electrons stay in orbit. That's what holds the atom together. Excuse me. Now, the other key point is, in an atom of an element, you will have the same number of protons as you do electrons. However many protons there will be the same number of electrons if it is an atom. That means atoms overall have 0 charge. Okay, so going back to the diagram again, in this example we have 11 electrons round the outside. That means there must be 11 protons in that nucleus. Even though you can't see some of them because of how the diagram's been drawn, there must be 11 protons in the nucleus because there are 11 electrons orbiting round the outside. And because of that, atoms have no charge overall. Okay, for each minus charge, for each -1 contributed by an electron, there is a positive charge of a proton. So in this case we have 11 electrons, 11 minuses. We therefore must have 11 protons, 11 positives. Positives and negatives cancel out, so overall the charge of an atom is 0. Remember, neutrons have no charge, so they do not contribute anything to that situation. Okay, right, moving forward then. From the periodic table, now you will have a periodic table in any assessment or exam that you do, we can get some information about these subatomic particles. Now the first key point is the little box for each element on the periodic table contains certain information. It contains the symbol for that element, which is a single letter or 2 letters or 3 letters. Okay, the abbreviated form of that element. It also usually will contain the name of that element, and it will contain 2 numbers. Now the smaller of those 2 numbers is the atomic number, and that tells you the number of electrons in an atom of that element. Now, as we've just said, the number of electrons is always the same as the number of protons. So if we know the atomic number of an element, we know how many electrons it has in each atom, that means we also know how many protons it has in each atom. And that's important for something we're going to move on to in a minute. So that's the first bit of information we can get from the periodic table. It tells us the atomic number, that tells you how many protons, and therefore how many electrons, an atom of that element contains. So in this case, this is carbon, it has the symbol C, and it has an atomic number of 6. That means each atom of carbon has 6 electrons and 6 protons. Okay, we'll come back to neutrons in a minute. So, identifying these could be 5, these are 5 elements from the periodic table. We've taken the names out, but we've got Na. Always, if there's one letter, it's a capital, 2 letters, capital and lowercase. 3 letters, capital, lowercase, lowercase, and so on. Only the first letter is a capital. So capital N small a, sodium, capital F small e, iron, capital S small n, tin, capital F, fluorine, capital A small I, capital A small L, aluminium. So, sodium, smaller of the 2 numbers is 11, that's the atomic number. That means an atom of sodium has 11 protons and 11 electrons. Iron, smaller of the 2 numbers is 26, so that's the atomic number. That means it has 26 electrons, 26 protons. Tin, smaller of the 2 numbers is 50. That means it has 50 electrons, 50 protons. Fluorine, the smaller of the 2 numbers is 9, therefore it has 9 electrons, therefore it must have 9 protons. And aluminium, the smaller of the 2 numbers is 13, so the atomic number is 13, that's what that is. That tells you it has 13 electrons in each atom, and therefore it must have 13 protons in each atom. So those are the atomic numbers of those 5 elements. Now the other number, if you look at each box, there's another number, a bigger number. That's what we call the mass number. Now the mass number is the total, or the sum, of the number of protons and neutrons in an atom of that element. That's what that bigger of the two numbers, that's what it tells you. That's what we call the mass number. Now remember, we said electrons have a very small mass. They are 1/2000th the size of a proton or a neutron, so we don't include those when we talk about the mass of an atom. When we talk about the mass of an atom, we talk about the mass number. That is the total of the protons and neutrons. So, looking at these three examples, hydrogen has 1 proton and no neutrons. Therefore, overall, it has a mass number of 1. Smallest element, smallest atom that we know of. Lithium has 3 protons and 4 neutrons, therefore it has a mass number of 7. 3 plus 4 is 7. Aluminium has 13 protons and 14 neutrons. 13 plus 14 is 27. It has a mass number of 27. So, very quickly, and this is very simple, I would pause the video and just calculate the mass numbers of these 5 elements. Do that just now if you like. Okay, so for helium, we have 2 protons and 2 neutrons in an atom of helium, therefore 2 plus 2, the mass number of an atom of helium is 4. Copper, we have 29 protons and 35 neutrons. 29 plus 35 gives us an answer of 64. That means the mass number of an atom of copper is 64. Cobalt has 27 protons and 32 neutrons. 27 plus 32 is 59, so the mass number of cobalt is 59. Iodine has 53 protons, 74 neutrons. 53 plus 74 is 127. Iodine has a mass number of 127. Germanium has 32 protons and 41 neutrons. 32 plus 41 is 73. Germanium has a mass number of 73. Hopefully you can see where these numbers have come from. It is not a difficult calculation. As in a lot of cases, well, certainly several cases in science, the calculation is not the difficult bit, it's knowing what numbers to put into the calculation. If you want to calculate the mass number, it's a simple addition, but it needs to be the number of protons plus the number of neutrons that you add together. Now, knowing that, therefore, if we know the mass number and the atomic number, we can calculate the number of neutrons. This is the third bit of information we can get about an atom using the numbers on the periodic table. Remember, the atomic number is the number of protons, and therefore it also tells you the number of electrons in an atom of that element. So atomic number of 2 means that element in each atom has 2 electrons and it also has 2 protons. Okay, so pause the video and try and fill in these gaps, then we'll go through them. Do that just now. Okay, so helium has a mass number of 4. It's an atomic number of 2. That means it has 2 protons, 2 electrons. 4 is the total of neutrons and protons, remember? So the number of neutrons is 4 is going to be the mass number minus the atomic number. So mass number 4, atomic number 2, number of neutrons is 2. 4 minus 2 is 2. Fluorine has has a mass number of 19. It has an atomic number of 9. That means it has 9 protons. So 19 minus 9, that means it must have 10 neutrons. Strontium has a mass number of 88, an atomic number of 38, so it has 38 protons. 88 minus 38, it must have 50 neutrons. Okay, zirconium has a mass number of 91. It has an atomic number of 40, so 40 protons. 91 minus 40, it has 51 neutrons in each atom. And uranium has a mass number of 238. It's an atomic number of 92, so 92 of those 238 subatomic particles are protons. That means the other 146 must be neutrons. Hopefully, again, you can see where we've got these numbers from. It's this simple calculation at the top. The number of neutrons is the mass number minus the atomic number, because the mass number is the total of protons and neutrons, and the atomic number tells you how many protons there are in an atom. Okay, that's the first video covering the first 4 fact points from your first lesson. I hope it has been helpful. Thank you.